Hello. Astrologers and astronomers often give a different time for a solar eclipse. So, for example, you go to a website that's by astronomers and they will give a certain specific time that an eclipse occurs. Then you go into your astrology software and it gives a little bit of a different time. And usually it's a difference of 3 or 4 minutes, sometimes as much as 10 minutes difference in time. And as you may know, if you're a student of astrology, the house cusps move about 1 degree in 4 minutes of time. So the house cusps can be different by 1 or 2 degrees, depending on whether you use the time that the astronomers say the eclipse occurs versus the time that astrologers say that the eclipse occurs. So what's going on here? Solar eclipse is an astronomical event. You think it would be very clear what time it occurs and why are we getting different times for the solar eclipse? Well, to understand this, let's first think about what a solar eclipse is. A solar eclipse is a special kind of a new moon. So there's a new moon every 29 days, and the word new moon, the term new moon, is another way of saying sun is conjunct the moon. So in an astrology chart, let's look at an astrology chart. This is an astrology chart for the 4th of January in the year 2011. And it's a solar eclipse. Well, as I said, a solar eclipse is a kind of a new moon. So we see the sun and moon are exactly conjunct. There's the sun at 13 degrees, 39 minutes of Capricorn, and the moon is also at 13 degrees, 39 minutes of Capricorn. And in fact, if we go to a listing of planetary positions that shows the positions to a second of arc, we'll see that they're precisely the same. So if I go to listing, planet or asteroids position list and planet positions list in the Sirius 2.0 software that I'm in, also the Kepler 8 software will work exactly the same way. We see that the sun is at 13 Capricorn, 38 minutes, 46 seconds. The moon is at 13 Capricorn, 38 minutes, 46 seconds. They're exactly conjunct to a second of arc. And in fact, let me show you this. If I go to the time adjust feature, this large purple clock here, it allows me to adjust the time of the chart. So I'm going to change it by seconds of time. Let's add, say, just a few seconds of time. Let's add 5 seconds. 5 seconds of time. So I'm going to change this chart to just very slightly later, and the time that it takes me to say something like very slightly later, that's like 5 seconds. Let's move that chart just a little bit in time, and let's see what happens to the sun and moon positions. I hit the right arrow to go 5 seconds later, and wow, the moon has moved 3 seconds of time. Let me go back, and let's just move 1 second of time. So I'm going to go 1 second of time later, and the moon has already moved to the next seconds. At 47 seconds, the sun is still at 46 seconds. I'll go 1 second back. Now I'm back to my original time, the time of the actual eclipse. Let's go 1 second earlier. They're still the same. Let's go 2 seconds earlier, and they're different. The moon is back at 45 seconds. So what happens is the moon moves about 1 second. It moves about, this gets confusing. We have seconds of arc and seconds of time. Let me just cancel out of this and get back to, and let's click on wheel, get back to our wheel. Okay, so I'm back to my solar eclipse chart. And as I said, a solar eclipse is a kind of a new moon. I'll explain why some new moons are solar eclipses and some are not. I'll explain that in a few minutes. But for now, just keep in mind that a solar eclipse, you might say, is a kind of special new moon. And the moon, what I was going to say is that the moon moves 1 second of arc in 2 seconds of time, approximately. So the time that's given here of 4 hours, 2 minutes, and 37 seconds in the morning, this is calculated for Washington, D.C., is exactly the time of the new moon And in this case, it's a solar eclipse. So it's exactly the time of the solar eclipse. If we move 2 seconds forward or 2 seconds backwards, it's slightly inaccurate. So the astrology chart appears to detect exactly when this eclipse occurs. And by the way, in the Series 2.0 software, I'll show you how you create this chart. If I just clear everything and go into the data entry screen, and right here you just select lunations and eclipses, and then you get a pop-up menu, and I select the top menu item, lunations and eclipses, and then you pick a date around the time of the eclipse. It'll find the nearest eclipse. I have here January 1st, 2011, and I can say whether I want all new moons or solar eclipses only, or all full moons, or all of the above, which would be all what we call lunations, new and full moons. And like I said, some of those new moons are solar eclipses, some of the full moons are lunar eclipses. Well, here I just selected, it doesn't matter. I'm just going to select solar and lunar eclipses only. It doesn't matter because I have a date of January 1st, 2011, and I'm asking for only one chart. I could put 5, 10, however many I want. And I click OK and click Done, and we get the chart we were just looking at. So anyway, that shows you how we get this eclipse chart, and it figures out the time of the eclipse to within seconds of time. So you see the sun and moon, when we go to that listing, are exactly conjunct. Okay, so very clear. Let's review a few points. Number one, the term new moon is another way of saying the sun is conjunct the moon. So new moon means the sun and moon are conjunct, and at new moon, the moon is not visible. When the sun and moon are conjunct, you can't see the moon because the sun is blotting out the moon, and that's why we call it new moon. And a new moon occurs approximately every 29 days, and some new moons are solar eclipses. And we're looking at the new moon on January 4th, 2011, which is also happens to be a solar eclipse. Now, let me show you why some new moons are solar eclipses and some are not, and this is important information to help us understand why it leads up to my explanation of why astrologers and astronomers often give different times for solar eclipses. Okay, a new moon is when the moon, this is the Earth, here's the moon going around the Earth, and this, let's call it silver or light blue or off-white line, whatever you want to call this, I'll just call it silver circle, represents the path of the moon going around the sun. And the yellow is the path of the moon going around the Earth. And this is the path of the sun going around the Earth. Well, the sun doesn't literally go around the Earth, but visually to us, we see the sun going around us. It's an optical illusion. The Earth is actually going around the sun, but we don't feel like we're moving. So we get this optical illusion that the sun looks like it's going around us, even though we're going around the sun. So from our point of view, both the sun and moon are going around us. Now, what this image is showing us is that they have different paths. They are two circles that are in the sky with us in the middle, but they're not exactly the same. It's like two hula hoops. Imagine you have this big hula hoop around you and another hula hoop around you that's tilted a little bit. And it's hard to read in this diagram, but it says 5 degrees. This distance is 5 degrees. So they're the two great circles, this circle of the moon's path and the sun's path, are very close to each other. They're only 5 degrees different, but they are 5 degrees different. They're not identical. And these two paths, the path of the sun and the path of the moon, intersect. They cross each other at opposite points. And these are the moon's nodes. So when the path of the moon comes up and crosses the path of the sun, that's the north node or ascending node. And then when it comes back around, this will be 14 to 15 days later, it goes halfway around, and then it hits the south node. So this whole cycle takes about 29 days for the moon to go around and catch up to the sun again. Now, here's the moon here. If it takes 29 days, well, it does take 29 days for the moon to go around. The moon was conjunct the sun, let's say 1 or 2 days earlier, right? Because we imagine the moon is going this way. Then a day or two earlier, it was conjunct the sun. That's new moon. So this moon is waxing. It's leaving the sun because the moon is much faster than the sun. So the sun's going to take a whole year to go around. The moon takes only a month to go around. So the moon is leaving the sun. It was new moon, say 1 or 2 or 3 days ago. The moon is leaving the sun. And when the moon was conjunct the sun was above the sun. Because the sun is here and the moon is here. So the moon passes the sun and goes above it. So it's not an eclipse. 29 days later, the sun will have moved and there'll be conjunct over here. And maybe in the next month, the sun will be here and the moon will be here. And at some point in the future, the sun and moon will both be on the descending node. So when the sun and moon are conjunct, the descending node or the ascending node, or what we call in astrology the south node or north node, you have an eclipse. Okay, so let me say that again. What happens is the path of the moon is a little bit different from the path of the sun, and when it's new moon, the path usually passes above the sun or below the sun. But if it happens to occur here at the south node, you'll have an eclipse. This sun and moon will be right in front of each other. Instead of the moon being above or below the sun, it'll be right at the same point, and you'll have a lunar eclipse. And you can say a solar eclipse when they're conjunct. If the sun and moon are opposite, it's called a lunar eclipse. So solar eclipse is when the sun and moon are conjunct, and they're also conjunct the south node or the north node. And that means the moon is right in the same direction, not above or below the sun. And in the case of the solar eclipse, on some places on Earth, you'll see the moon move right in front of the sun. And at the lunar eclipse, you'll see the shadow of the Earth cover the moon. So they're lined up perfectly. And this will happen approximately every 6 months, about twice a year. There's an eclipse season when these eclipses occur as the sun gets to these points that are on the nodes. And these nodes, by the way, are also moving. They move overall in a retrograde motion. So it's a kind of complex thing. So that's what an eclipse is. A solar eclipse is a special new moon where the moon is not above or below the sun. It's right on the sun. And this distance of the moon from the sun's path, above or below, is called the ecliptic latitude. That's the latitude of the moon. So when the latitude of the moon is near 0, you'll have a solar or a lunar eclipse, and that also is the definition of the north node and south node. Okay, so we have an idea of what eclipses are. Now, this just reviews what I just said. I don't think I need to go over this. So let's just read my last sentence here. So why do astronomers not consider this to be the time of the solar eclipse when the sun and moon are exactly conjunct? And I'm going to explain this in another diagram. Here is why. Okay, this has got a lot of information to it, so let me walk you through this little by little. What I have here is a horizontal line. And this horizontal line represents the path of the sun. And this red, here I call it orange, but it looks more red to me right now. Whatever it is, red or orange, I'll call it red. This red circle is the sun, and and this is the path of the sun, traveling in the sky. This is the same thing I'm showing here in a more three-dimensional. This is the sun moving along this path. Okay, but I'm just making it not three-dimensional. I'm making it flat because it's easier to demonstrate something. And these 3 black circles show the moon at 3 different times. So let's call this time here 8:30. So this black circle is the moon at 8:30, and I have it moving from left to right. It doesn't matter, but in this I've got the planet's moving in this direction to our right. So here's the moon at 8:30. Here's the moon at 8:40, the second ring, and here's the moon at 8:50. So you got the idea? I'm just showing the moon at 3 different times. Across that 20 minutes of time from 8:30, say it's 8:30 in the morning to 8:50 in the morning, during that 20 minutes, the sun hasn't moved much. We can consider it to be almost still. In 20 minutes, the sun just doesn't move very much. It moves very, very slightly. Okay. So here's the moon moving. Well, this is showing the issue that comes up is that the moon is not in the same circle as the sun. This is the same thing I showed you in the previous diagram. It's in its own circle, so it might be coming down. So in this case, I'm showing the moon getting closer to the sun's path. And this black line, black slightly curved line, is the path of the moon. And this red line is the path of the sun. So you see what's going on here. It's not as simple as the moon and the sun being on the same circle, and then you just see when the moon sits on top of the sun. No, the moon has its own path, a little bit different from the sun's path. Now, in astrology, we consider the new moon to occur with this purple vertical line. Here's the moon, and here's the sun. So when the moon passes the sun and it's directly above it in relationship to the path of the sun, this is the time, 8:30 is the time I'm calling this. 8:30 is the astrological new moon. And this is an eclipse. What I'm showing here is a partial eclipse. Eclipse means that the circle of the moon overlaps the circle of the sun. The sun and moon are overlapping. The moon does not go completely over the sun. This is a partial eclipse. If the moon came right directly, perfectly on the sun, that would be a total eclipse. So I'm showing a partial eclipse, and this time, 8:30, is the time of the eclipse according to astrologers. Because in astrology, what we're interested in is zodiac longitude, where the moon is, if we place it on this, what's called the ecliptic path, the path of the sun. So you can think of it as dropping it 90 degrees. It's called projecting in astronomy. We give the position of the moon as right here. So this time, 8:30, is when the sun is conjunct the moon. Now what astronomers do is they don't measure in zodiac longitude when they are calculating eclipses. They see when the sun and moon are closest. That's the difference. And you see there's a logic to that. I mean, it makes sense. Astronomers are going to explain it visually. When are the sun and moon overlapping the most? And it might be, I've drawn a light blue line here, maybe the moon is slightly overlapping the sun more a few minutes later when the moon gets here. So I don't know. I mean, these all look like pretty big overlaps, but let's just imagine that when the moon gets to here, the second of these rings, is when it's overlapping the sun more. And the astronomers call 8:40, this is occurring later. If this is 8:30, this is around 8:40, is when the eclipse occurs, when the moon has the greatest overlap with the sun. So because the moon's path is at an angle to the sun's path, the moment when the moon and sun overlap each other can be slightly different from the time that astrologers use when the moon is directly above or below the sun in relationship to the path of the sun. Well, I hope you follow that. It's actually a fairly simple idea, but if you're new to thinking about this, maybe you want to watch this video a few times. But that's the difference. And this blue line is a line going from the center of the sun to the center of the moon, and this is the direction the moon is in from the sun. So when this blue line, basically this blue line from the center of the moon to the center of the sun, when its distance is the shortest, when the center of the sun to the center of the moon, when that line is the shortest, the sun and moon have the most overlap. And maybe that occurs when the moon is over here. And that's why you can get up to about 10 minutes different. So, to summarize, the eclipse occurs, according to astrologers, when the sun and moon have the same zodiac longitude, this measurement along the path of the sun, also known as the ecliptic plane, is the zodiac longitude. So when the sun and moon have the same zodiac longitude, means the moon is directly above or below the sun, that's the time of the eclipse. According to astronomers, they're going to look at when the sun and moon have the greatest overlap. And so you get these differences. Okay, so let's look at the difference in this particular eclipse. This is a partial solar eclipse on January 4th, 2011. And by the way, notice the sun and moon, both at 13 Capricorn 39. Where's the moon's north node? 2 Capricorn 47. About 11 degrees from the sun and moon. That 11 degrees is close enough to the sun and moon to be a partial eclipse. So if the north node or south node is very, very close to sun and moon, you'll get a total eclipse. When it's farther away, you get a partial eclipse. And if the node was way over here, then there's no eclipse at all. So you will notice that every eclipse occurs when the north node or south node is near the sun and moon. By definition, it has to be, because that node point is where the moon would have no latitude. It would be crossing the path of the sun. That is where the path of the moon crosses the sun. At that point where the sun and moon's paths intersect is where the sun and moon are, you have an eclipse. Okay, well, our astrological solar eclipse occurs with the ascendant at 27 Scorpio 46. And I already showed you the listing that shows that the sun and moon are exactly conjunct. Now, let me go back into the data entry screen. I'll go to New, and I'll go to View or Edit Chart Data. I'm going to go to Lunations and Eclipses. Select the Lunations and Eclipses again. And over here is a button for Calculation Method. And it's telling me my current method is astrological. I'm going to click on Calculation Method. And I'm going to change it to astronomical. So astronomical means measured the way astronomers do it. Click OK. Now this is going to be interesting. Let's click on Done now that I have astronomical selected. And up here, when it describes what kind of chart this is, it says it's a solar eclipse astronomical. So what Kepler 8 and Sirius 2 do is they will let you know whether you're looking at an astrological solar eclipse chart or an astronomical solar eclipse chart. And so this chart is going to occur a little bit earlier in time. And if you go to an astronomy website, you're going to find that the time given here is within seconds of time of the time given by astronomers. It's very difficult to calculate these things to a second of time. House cusps only move 1 minute every 4 seconds of time, so it's extremely precise. You're going to get almost exactly the same exact time if you see what astronomers give as the time. This is the time when the sun and moon have greatest overlap. It's a little bit earlier, and look at the ascendant. It's 25 Scorpio 22. So in my PowerPoint presentation, I mentioned this to summarize. The ascendant of the astrological solar eclipse is 27 Scorpio 46. For the astronomical solar eclipse, it's 25 Scorpio 22. And there you see 2 degrees, a little over 2 degrees difference, and that's not unusual. You'll see sometimes only a half a degree difference in the ascendant, or 1 or up to 2 degrees, sometimes close to 3 degrees different. Of course, the ascendant changes speed. If it happens to be a time of day and a location where the ascendant's moving very fast, you can end up with way more than 2 degrees difference, depending on where the chart is being calculated for. So you'll get some difference in the house cusps. Now, 2 more things I want to say, and we're covered everything I want to cover in this tutorial video. One is that lunar eclipses have the same exact issue as solar eclipses. The only difference with a lunar eclipse is the lunar eclipse occurs at full moon, In other words, when the sun and moon are opposition, rather than at new moon, which is a solar eclipse. And it's the same exact thing. Some full moons are lunar eclipses. As I mentioned before, lunar eclipses also occur when the sun and moon are on the moon's nodes. And again, you'll get the same kinds of differences in time for lunar eclipses between the astrological and the astronomical calculation. Now, last thing, does it matter? Who cares about 25 Scorpio versus 27 Scorpio in the ascendant? Well, for most things astrologers use the eclipses for, it does not matter. Because the most common thing astrologers do is they're doing charts of their clients, and they want to see where the eclipse occurred. And so this particular eclipse occurred at 13 degrees Capricorn, and the idea is if you have a planet at 13 degrees Capricorn, you're getting, as people say, hit by the eclipse. Like if your Venus is there, the eclipse is on your Venus. That's the thing. Sometimes people take aspects, sometimes they look at other planets as well. But if you're just looking at the eclipse point, where the sun and moon are, it's not going to matter. Because in 10 minutes of time, the sun and moon don't move very much. However, here's where it does make a difference. Some astrologers interpret eclipse charts to predict the weather or predict political events. So here I did the eclipse for Washington, D.C. This is a common thing done to see what will happen in the United States. The belief is you do a chart for the capital of the country, and whatever's going on is affecting the country at that time. And new moons, and especially solar eclipses, are believed by great numbers of astrologers, probably the majority, that they have a tremendous impact. So what if the president's Neptune is at 27 Scorpio? Using the astrological eclipse, the ascendant would be right on it. Using the astronomical eclipse, it's a 2-degree orb. Well, in the astrology I do, 2 degrees versus no orb at all is huge. A lot of people are going to have a planet within 2 degrees. So it makes a difference if you're calculating solar eclipses to do political astrology or weather prediction, or for any other reason you want to calculate the eclipse for a specific place and interpret it, then it makes a difference. And again, that's not what's usually done with clients. So this difference does not make has no effect on normal consultations where we're just looking at the eclipse point. But there are other situations where it makes a very big difference, and then you run into this problem of why are the astronomers giving a different time than the astrologers? Which time should I use? Well, if your software gives you a choice, you can choose either way you want to do it, as we've seen here with the Sirius 2 software. Also Kepler 8 gives you that option, and I believe many other astrology programs do as well. So you have that choice. Personally, which one should you use? I believe you should use the astrological one, because in terms of astrology, I think it's the zodiac position that matters. That's just my opinion. I think we need a lot more research on this. Maybe some astrologers have done research on it. It would be interesting to see what they found out. Okay, well, that's it, my friends. I wanted to make that clear. This is a question that does not come up very often, but every once in a while an astrologer runs their astrology software, says, here's my eclipse chart, and then they happen to go to an astronomy site or a calendar that's based on astronomical calculations at a certain website, and why is it giving a different time for this? And you'll even see different times for new moons and full moons, not just the eclipses, but you'll see that as well, because they're being also measured in a different way. Sometimes what's called right ascension. There's different ways of looking at this, different issues brought up. But here I focused on eclipses and why the time is different depending on whether you calculate it with the astronomical concept of shortest distance versus a astrological concept of when they're conjunct in zodiac longitude. That's it, my friends. Thank you for listening. I've got up here the link to the Cosmic Patterns software website where we make the Sirius programs and the Kepler program, the YouTube page for all the lessons, also other websites. I also work for Matrix Software, so we have 2 lines of software. That's at astrologysoftware.com. Online charts and star guidance, our astrology school, and other services at this website. Okay, my friends, thank you very much for listening. God bless. Namaste.